We have previously learned about the Bronsted-Lowry theory of acids and bases. We will now learn about conjugate acids and bases using our knowledge of the Bronsted-Lowry theory. Let's do a quick warm-up. Vinegar is a 5% aqueous solution of acetic acid. Vinegar is used in cooking worldwide and is sometimes used as a cleaning agent. From the equation which describes the behavior of acetic acid in water, could you identify the Bronsted-Lowry acid and the Bronsted-Lowry base? Pause and resume when ready. The Bronsted-Lowry acid is acetic acid because it releases a proton. Water accepted a proton from acetic acid, so it is a Bronsted-Lowry base. As we have learned, an acid-base reaction, all according to the Bronsted-Lowry theory, involves the transfer of a proton. Let's now look at what has been formed from this reaction. The acetic ion is formed when acetic acid released the proton. The acetate ion is the conjugate base in this reaction. Can you remember what this is called? Pause and resume when ready. This is hydronium ion, also known as oxonium ion. The hydronium ion is formed when water accepted a proton from acetic acid. This is a conjugate acid in this reaction. When a Bronsted-Lowry acid releases the proton, the resulting species is its conjugate base. When a Bronsted-Lowry base accepts a proton, the resulting species is its conjugate acid. Acetic acid and the acetate ion is a conjugate pair. Can you identify the other conjugate pair in this reaction? Pause and resume when you're ready. Water and hydronium ion is the other conjugate pair. So when acid and its conjugate base is a conjugate pair and a base, it is conjugate acid is also a conjugate pair. Now you are ready for a challenge. For this reaction, try to identify in the Bronsted-Lowry acid the Bronsted-Lowry base, the conjugate base, the conjugate acid and the conjugate pairs. Let's grab a piece of paper and pencil, pause the video and resume when ready. The Bronsted-Lowry acid is sulfuric acid as it releases a proton to ammonia. Since ammonia accepted the proton, it is the Bronsted-Lowry base. The hydrogen sulfate ion is the conjugate base of sulfuric acid. The ammonium ion is the conjugate acid of ammonia. Therefore, sulfuric acid and hydrogen sulfate ion form a conjugate pair and ammonia and the ammonium ion form another conjugate pair. In summary, a conjugate base is formed when a Bronsted-Lowry acid releases its proton. Conjugate acid is formed when a Bronsted-Lowry base accepts a proton. A Bronsted-Lowry acid and its conjugate base is a conjugate pair, as is a Bronsted-Lowry base and its conjugate acid.